Okay, this is 7.2b. Estimating a population mean using T. So here's the three things we have learned in this section or this unit. The first one, confidence intervals with proportions. Confidence intervals with means using Z. Confidence intervals today, estimating the population mean but using T. So how do I know when to use T star, which I'm going to tell you what that means in a second. How do I know when to use that versus what we did in the last section, which was Z star?
Standard deviation is in the problem.
This one is when population standard deviation is unknown. So it only gives you a sample standard deviation, or it does not give you population standard deviation. So we're going to identify in the problem the differences from last section to this section. Everything else remains exactly the same. Conditions? Does everyone have that written down?
Oh, no.
Okay. Okay, conditions are the same, so I wrote them down for you. Random sample, or if it doesn't say random sample, then we say that the sample is representative of the population. That's if it doesn't say it's a random sample. We assume that the sample is representative of the population. That's if it does not say it's random. Then second is checking if it's normal. It has to be one of the following. It's either given to you in the problem, sample size is greater than or equal to 30, or you have to check the normal probability plot and the box plot. We want the normal probability plot to be what? Linear, and we want the box plot to have no outliers. Here are the differences between normal distribution, which is Z, versus a T distribution. So some similarities and differences. They are both bell-shaped, so they both look like this. But the T distribution is a little bit wider. It has more area in the tails, and it changes. So normal distribution is always centered at 0, has a standard deviation of 1. A T distribution is still centered at 0, but it fluctuates based on something that we call degrees of freedom. I'm going to explain what that means in a second, or what that is. So I'm going to let you write that down and then I'll explain it. Okay, so when we talk about the normal distribution, it does not change. So it doesn't change. It's always set. But the T distribution changes based on sample size. So if my sample size is really small, like n equals 1 or n equals 2, it's going to be wide or wider versus if n equals 31. It's going to be skinnier. So this is what this last bullet point is saying. As your degrees of freedom increases, which is the same thing as saying your sample size increases, it's going to get closer and closer and closer to a normal distribution. Your degrees of freedom is equal to sample size minus 1. You do need to memorize this. So that's not given to you as a formula.
What is
Degrees of freedom. DF equals n minus 1, or sample size minus 1. If I were to explain what degrees of freedom were, I'm going to try to make this as simple as possible. Imagine that this class, I said every single table in here, so tables of 4, every single table in here needs to collectively make an average of an 88 on the test. So, as a team, you're going to make an 88. 3 of you, or you each take the test. I start grading. First person makes a 92. That's awesome. Second person makes a 57. Oh no. Third person makes a 100.
Wait, mine's 57.
So this person right here means they have to make a fixed value. Like it is up to them. The pressure is on this person to make a certain grade so that your average equals an 88, right? So because you would add these, divide by 4, and you want that to equal 88. You want their average to be 88. So that means that you have, if my sample size is 4, I have 3 degrees of freedom, meaning 3 people can make whatever they want, but then that 4th person is a fixed value. So if I have a sample size of 4, I have 3 degrees of freedom. 3 people can be whatever they want. The 4th person cannot. So short answer, degrees of freedom is always n minus 1. You can memorize that. But understanding it conceptually, that's what it means. Conceptually. Thank you. Okay, so the critical value will now be T star instead of Z star. So we're going to solve it the same way that we did the last one. But instead of inverse norm, we're now going to use something called inverse T. So, second vars, inverse T. But it's the same process. So you go halfway to 100, but instead of 0 and 1, it is your degrees of freedom, which equals what? N minus 1. So it has to give you a confidence level and a sample size in order to do this inverse T. So let's try one together. 95% confidence, N equals 15. So in my calculator, it would be inverse T. What would halfway to 100 be? 0.975. And then what goes in the next blank? 15 minus 1, 14. 2.14?
Actually,
Wow, gee, that's pretty cool. We're calling her inverse.
0.995 and
0.995, 42.
That's doing good.
What do you get?
2.6, 2.67. I can't round. No, it's a rounding. 2.7. How would you round that?
And then the last one, 80% confidence, N equals 30. What would I do? Inverse T, 0.9. What is it? Yes.
Yeah, where is it?
You go to second vars. Oh, on the Inspire. Okay, here's calculations. Shh. What's my point estimate? Also, this is T interval. In this formula, what's my point estimate?
X bar.
X bar. What's my critical value?
T star.
T star. What's my standard error?
S.
S divided by the square root of n. What's my margin of error?
T star.
T star. S divided by square root of n. How is this formula different from the one we learned in the last section? What 2 things are different?
Everything.
T star and S. Yes. S is your sample standard deviation.
Wow. Okay.
So in the last section, when we use Z, it's Z star and then sigma over the square root of n. So these 2 will always go together. T star and S will always go together. Then our conclusion, we are blank % confident that the true population mean is between this and this. Okay, let's try one example together, then you are going to be free to do the rest on your own.
This T.
Okay, I want you to read this and then highlight the important numbers.
Someone throw a highlight.
Or circle the important numbers.
If you do it in front of me,
Circle the important numbers. What are the numbers that we need? Do we need this 110? No, we don't really need it. Not right now.
We need 102.
He uses the drug on 30 patients. That's my sample size. Sample mean is 102. Sample standard deviation is 3.2. Construct a 90% confidence interval. And it also tells me that they are normally distributed. So, for my conditions, does it say it's a random sample? No. So we assume.
Representative of the population.
Yes. Whoops, that's not how you spell assume. Assume sample represents population. Second one. So normally distributed because it's given.
Is CLT gone?
No, that's whenever CLT is the greater than 30.
Oh.
Yeah, it's given. Okay, 2 critical value.
1.7.
I need to do inverse T
0.95.
0.95, comma 29. Calculations.
Why do you hit me?
So it is x bar plus or minus t star s divided by the square root of n. I'm going to plug in my values, which would be 102 plus or minus 1.7, 3.2 divided by the square root of 30. But I don't have to do this in my calculator because I can run the t interval test in my calculator. So it is under stat, test, t interval. You're going to use stats where you're going to be plugging in the 102, the 3.2, and the 30. T interval. Yes, you do. Under confidence intervals.
It's number 8, right?
Did you say T interval?
T interval, yes.
It's that.
Okay, what is it? How much I have stats, test, stats? Yeah, I did it right.
What do you get?
101.01.
101.01. 10. Is that what other people got?
I hope so, I wrote that down. I got that. No. Yeah, I got it. Well, I guess you can round it. I got it.
Okay. Then my conclusion, I'm going to erase all of this. Or I'm just going to erase the top. So conclusion is we are
90% confidence.
that the true population mean, what are we measuring? Blood glucose concentration. Is between 101.01 and 102.99 mg/dl. Okay, then the next question, the follow-up. It says, so the follow-up question says, is this successful? How would I know? How do I know when it's successful?
If it's in between,
If it's below 110. So,
Oh, because it said that in the thing.
so the drug is considered successful if it can lower blood glucose concentration below 110. Is my entire interval below 110?
yeah.
Yes.
Oh, wait, what?
Yes. Jeez. So, yes,
Yes, because
it is successful because the entire interval, that's not how you spell interval, interval is less than 110. That's something you might see on like a My Math Lab. Those are the follow-up questions that you see. So if it's all of that below, if it contained 110, listen, please. If it contained 110, it would not be successful, even if the whole thing would have to be below.
Got it.